Hi, this is the presentation about aquifer storage and recovery in the state of Washington by Hussein, Max, and Kirsten for Engineering Geology 1. To review, an aquifer is an underground layer of permeable rock or unconsolidated materials such as gravel, sand, silt, or clay that yields water. And on the figure we can see aquifers shown to the bottom left. With aquitard separating them, which we'll explain on the next slide. And also this figure is important because it shows the overall hydrologic cycle that sustains aquifers and involves the human uses of aquifers. Just to review some of the basic vocabulary related to aquifers, confined aquifer is an aquifer that is trapped between a dense and impermeable layers. An unconfined aquifer is that which has no upper boundary. Its upper boundary is the water table, which may be below or above the ground surface. An aquitard is an impermeable layer that restricts the flow of groundwater and may limit the size or define the boundaries of an aquifer. An aquiclude is a completely impermeable aquitard where no water will pass. And the vadose zone is a zone between the ground surface and the groundwater level, or in our case, the saturated aquifer. And this zone protects the aquifer from the elements above the ground, possibly pollution. Some hydraulic characteristics that are important to remember when discussing aquifers in an engineering sense are conductivity, which is the ease with which water moves through the pore space and fractures of the aquifer. Typical values of this range from 0.01 to 20 meters per day. Transmissivity, which is in the units of square distance per time. It measures how fast this water can move horizontally throughout the aquifer, typical values ranging from half to 500 square meters per day. And storativity, which is the volume of water released per unit decline in the hydraulic head per unit area of the aquifer. Our main topic will be aquifer storage and recharge, and there are about 100 aquifer storage and recharge projects, or ASR projects, in the United States, 12 of which are in the state of Washington. Some of the projects we'll be discussing are the North Bend Aquifer, which is a 100-foot thick aquifer 200 feet below the surface. The Yakima Aquifer, which has our annual recharge of over 5,700 cubic feet per second. The Lake Haven, Walla Walla, and Redmond aquifers. And some aquifers that are not current ASR projects but are either relevant or will become ASR projects that we're going to briefly cover are the Spokane Aquifer, the Columbia Aquifer, and the Puget Sound Aquifer system. The main purpose of aquifer storage and recovery is to store water when it is naturally available so that it will be there for human use when water is scarce. Water is becoming more in demand due to increases in population and climate changes affecting the hydrologic patterns. Storing water underground, as opposed to in dams or reservoirs, helps maintain base stream flows, which supports fish. Other benefits to keeping water stored underground are that it prevents saltwater intrusion. Not replacing the groundwater can cause a reversal of direction of flow, or instead of fresh water flowing from land to sea, the seawater seeps into the land and contaminates fresh drinking water, rendering it unusable for human consumption. In addition to this, if groundwater levels are lowered by pumping and not recharged, stress states change significantly within the soil, which can result in its engineering properties weakening, and subsidence may occur. Sites that do well with ASR have a high conductivity so that water can flow quickly into the aquifer without pooling on top. Good storage and recovery aquifers also have a low concentration of total dissolved solids to maintain the water quality of the water pumped into the aquifer and to prevent having to do any additional treatment when the water is pumped out later. Homogeneous aquifers hold the water more closely to increase recovery percentage, and mix less to reduce the chance of contamination. Strong aquifer materials are preferred to prevent subsidence and collapse from changing in the water table and pressure.